Hello, everyone, and welcome to Fun Steps Academy. Today, we will talk about how earthquakes happen. What makes the ground suddenly shake? One moment, everything is calm. The next, buildings tremble, roads crack open. The ground itself moves beneath your feet. Earthquakes are one of the most powerful and terrifying natural events on Earth, but they are not random. They are not mysterious. They follow rules, geological rules, that science has spent centuries uncovering. Today, we go beneath the surface and find out exactly why earthquakes happen. The structure of the Earth. To understand earthquakes, we must first understand what is beneath us. The Earth is made of four main layers. The crust, the outermost layer, the solid ground we live on. Two types: continental crust, thick, less dense, makes up land. Oceanic crust, thinner, denser, makes up ocean floors. Thickness, 5 to 70 kilometers. The mantle, below the crust, made of solid rock, but under extreme heat and pressure, it behaves like a very slow-moving fluid. Thickness, approximately 2,900 kilometers. Blue, the outer core, made of liquid iron and nickel, generates Earth's magnetic field. The inner core, solid iron and nickel, extreme pressure keeps it solid despite enormous temperatures. The crust and upper mantle together form a layer called the lithosphere. This lithosphere is not one solid piece. It is broken into massive sections. These sections are called tectonic plates, and they are the root cause of earthquakes. 3. Tectonic plates, the engine of earthquakes. The Earth's lithosphere is divided into approximately 15 to 20 major tectonic plates. These plates are constantly moving, very slowly, just 2 to 10 centimeters per year, about the same speed your fingernails grow. But over millions of years, this movement reshapes entire continents. Types of plate boundaries. There are 3 types of plate boundaries, and each produces a different kind of geological activity. Convergent boundaries, plates moving toward each other. When two plates collide, one is pushed beneath the other. This process is called subduction. The subducting plate sinks into the mantle. The friction and stress cause powerful earthquakes. Divergent boundaries, plates moving apart. When two plates pull away from each other, magma rises from the mantle to fill the gap. New crust is formed. This process is called seafloor spreading. Earthquakes here are generally less violent. Transform boundaries, plates sliding past each other. When two plates slide horizontally against each other, enormous friction builds up. When the stress is released, a powerful earthquake occurs. Fault lines, where earthquakes are born. A fault is a fracture or crack in the Earth's crust, where blocks of rock on either side move relative to each other. Faults exist along plate boundaries, but also within plates. Types of faults: normal fault, rock moves downward due to tension. Reverse fault, rock moves upward due to compression. Strike-slip fault, rock moves horizontally, like the San Andreas fault. Stress builds up along fault lines over years and decades. The rocks on either side lock together through friction. Stress continues to accumulate until finally the rock cannot hold anymore. It breaks and slips suddenly. That sudden release of energy is an earthquake. 6. Hypocenter and epicenter. Every earthquake originates at a specific point underground. This point is called the hypocenter, or focus. It is the exact location where the fault ruptures. The point on the Earth's surface directly above the hypocenter is called the epicenter. The epicenter experiences the strongest shaking. Damage decreases as distance from the epicenter increases. Shallow earthquakes with hypocenters close to the surface cause far more destruction than deep earthquakes. Seismic waves, how energy travels. When a fault ruptures, energy is released in the form of seismic waves. These waves travel through the Earth in all directions. There are 2 main types of seismic waves: P waves, primary waves, the fastest seismic waves. They compress and expand the rock as they travel. They can travel through solids, liquids, and gases. They arrive first at any location, hence primary. S waves, slower than P waves, they move rock up and down and side to side. They can only travel through solid material. They arrive second, hence secondary. S waves cause more structural damage than P waves. Surface waves travel along the Earth's surface, slowest but most destructive. They cause the rolling and shaking felt during an earthquake. A seismograph is the instrument used to detect and record these waves. 8. Measuring earthquakes. How do scientists measure the strength of an earthquake? The Richter scale, developed by Charles Richter in 1935, measures the amplitude of seismic waves. Logarithmic scale. Each whole number increase represents 10 times more ground motion. A magnitude 6 earthquake is 10 times stronger than magnitude 5. The moment magnitude scale, MMS, be modern standard used by scientists today, more accurate than the Richter scale for large earthquakes, also logarithmic. General magnitude guide, below 2.0, not felt by humans, 2.0 to 4.0, minor tremors, 4.0 to 5.0, felt widely, minor damage, 5.0 to 6.0, moderate damage, 6.0 to 7.0, strong, serious damage, 7.0 to 8.0, major, widespread destruction, above 8.0, great earthquake, catastrophic damage. The 2004 Indian Ocean earthquake measured 9.1, one of the most powerful ever recorded. Earthquakes and tsunamis. When a powerful earthquake occurs beneath the ocean floor, the sudden movement of the seabed displaces enormous volumes of water. This displacement creates a tsunami. Tsunami waves in deep ocean travel at speeds up to 800 kilometers per hour, have wavelengths of hundreds of kilometers, are barely noticeable at sea, only 1 meter high. As they approach shallow coastal waters, they slow down, their height increases dramatically. They can reach 30 meters or more. The 2004 Indian Ocean tsunami, triggered by a 9.1 magnitude earthquake, killed over 230,000 people across 14 countries. It remains one of the deadliest natural disasters in recorded history. 10. Earthquake zones and the Ring of Fire. Earthquakes do not happen randomly around the world. They are concentrated in specific zones, along plate boundaries. The most seismically active zone on Earth is called the Ring of Fire. It is a 40,000-kilometer horseshoe-shaped zone encircling the Pacific Ocean. This is because the Pacific plate is surrounded by subduction zones, where plates are constantly colliding and diving beneath each other. Great! Now let us have a multiple-choice quiz to see what you have learned. 1. What are the large sections of Earth's lithosphere called? A. Seismic zones. B. Fault lines. C. Tectonic plates. D. Mantle layers. The answer is C. Tectonic plates. 2. What type of plate boundary involves one plate sliding beneath another? A. Divergent boundary. B. Transform boundary. C. Convergent boundary with subduction. D. Strike-slip boundary. The answer is C. Convergent boundary with subduction. 3. What is the exact underground point where an earthquake originates? A. Epicenter. B. Fault line. C. Seismic zone. D. Hypocenter. The answer is D. Hypocenter. 4. Which seismic wave travels the fastest? A. S wave. B. Surface wave. C. P wave. D. Love wave. The answer is C, P wave. 5. What drives the movement of tectonic plates? A, ocean tides, B, Earth's rotation, C, convection currents in the mantle, D, volcanic eruptions. Answer is C. 6. What does the moment magnitude scale measure? A, wind speed during earthquakes, B, the strength and energy released by earthquakes, C, depth of the hypocenter, D, height of tsunami waves. Answer is B. 7. Where do approximately 90% of all earthquakes occur? A, the Mid-Atlantic Ridge, B, the Himalayan Belt, C, the Ring of Fire, D, the African Rift Valley. Answer is C. How does an underwater earthquake cause a tsunami? A, it heats the ocean water, B, it displaces large volumes of ocean water, C, it creates strong winds, D, it increases ocean depth. Answer is B. Finally, it is time for the fun fact of the video. Did you know? The deepest earthquake ever recorded occurred at a depth of approximately 750 kilometers beneath the Earth's surface, in the mantle itself. Scientists call these deep focus earthquakes, and they challenge our understanding of how and where rock can fracture under extreme pressure and temperature. Isn't that interesting? The ground beneath your feet is not still. It never has been. For billions of years, tectonic plates have been moving, colliding, separating, and grinding, building mountains, opening oceans, and releasing energy in the form of earthquakes. Thank you so much for watching. Please like and subscribe to Fun Steps Academy. See you in the next one.